So now that we've done limits algebraically and we've looked at them graphically, the next part that we're going to look at is trig functions. So all the stuff that we've done about limits doesn't really tell us anything about trig functions. How are you going to factor out trig functions? That doesn't make sense, or anything like that. So what section 2.6 is going to be discussing is trig limits. So trig limits. So this is where we're going to look at things like sine, cosine, tangent, things like that. So one important thing that we're going to use is that for any x, sine is between -1 and 1. So the sine function, if you remember, the graph of it just bounces back and forth between -1 and 1, so sine is bounded -1 to 1. Also, cosine is bounded between -1 and 1, and we're going to use this over and over again. What this is saying is that the y values of sine and cosine never are larger than 1, and they're never less than -1. What this is going to lead into, this idea of bounding, is the squeeze theorem. So the idea behind the squeeze theorem is that if we can take something, let's call it a heart for right now, and we can bound it above by, let's say, the number 5. And we can also bound it below by also 5. So if I can say that this heart is greater than or equal to 5, but also less than or equal to 5, this means that the heart has to equal 5. So if I can bound something above and below by the same number, then I have to have that heart is equal to 5. So that's the idea of the squeeze theorem, is that if I can take something and squeeze it in between the same number, then that something has to be that number. So this is the basic idea of the squeeze theorem. Here's the actual statement of it. It says, let's assume that for x not equal to c, in some open interval, containing c, we can bound f of x between two functions. So we can bound f of x between, let's say, a function L and then above by a function u. So if we can take a function f of x and bound it above and below, where the limit as x approaches c of L of x is equal to L, and that's also equal to the limit as x approaches c of u of x, then the limit as x approaches c of f of x has to be that same L. So this is what the squeeze theorem says, and we'll write it a little bit differently so that it's more clear, but the basic idea is that I'm going to take my function f of x, and I'm looking at the limit of f of x. I'm going to bound it between two functions where the limit of those two functions is the same. Then that means the limit of f of x has to also be L. So, what are we going to do? We're going to start with the limit. It's going to say something like the limit as x approaches c of f of x. We're not going to know how to do this one algebraically because it's going to involve probably trig. So what we're going to do is we're going to find an L of x and a u of x with the same limit. And this is the important part. The same limit as x approaches c, and I need to bound it above and below. Okay, so I'm going to start with a function f of x where I'm looking at the limit. I'm not going to know how to do this one directly, so I'm going to bound it by an L and a u where these two functions have the same limit. Then what I can say is that the limit of all three functions is the same. So L of x, and this is also equal to the limit of u of x. So that's what the squeeze theorem says, is that if you start with a function, I bound it above and below where these two functions have the same limit as I'm approaching c, then all three of them have the same limit. So that's the squeeze theorem, and we're going to do some examples. Before we do some examples, there are two important trig identities that we're going to use. So important trig limits. The first one is that the limit as theta approaches 0 of sine theta over theta is 1. That's our first limit. And our second one is that the limit as theta approaches 0 of 1 minus cosine theta over theta is 0. So these are the two important trig limits that we're going to use. So we're going to use these two limits plus the squeeze theorem to look at a lot of different limits of trig functions. So this is kind of the basis of this section, is that the squeeze theorem can bound a function between two other functions that'll tell us the limit, or we could use these two identities. So with those kind of two things, that's how we're going to look at limits of trig functions.